So we have completed this problem in ANSYS. Next is verification step that we should always perform before concluding any results. So these are the verification steps. Check that solution agrees with the mathematical model. Are boundary conditions on deformation and traction satisfied? Yes, we have checked that at the both fixed end we are getting deformation of 0 mm as those are fixed support. Is equilibrium is satisfied? That we are going to check now, as it is a statistically undetermined kind of problem. Check that numerical error is acceptable. So are ANSYS results reasonably independent of mesh? Currently we have given one element across one step of bar. You can give 2 or 3 and you can by yourself verify that results are not affecting or not changing by giving extra meshing. And the last and very important part, check comparison with the hand calculation for stresses and other parts. So that we are going to do in this session. First, let's find out the forces. For that, we should do the free body diagram first. Yeah, this is a governing equation which you're already familiar with in ANSYS. So ANSYS solves this governing equation that we have already discussed. So this is our problem, and I have created a free body diagram for you. Here it's fixed end, so let's consider this fixed end to be A, this end fixed end to be B, reaction at A to be positive, let's consider that to be AX, reaction at BX to be considered as negative. It may be positive, but we are right now assuming it's negative. So we are considering the reaction BX at the B end. And these are the forces which are applied on this. So what we are going to do, we are going to first make a free body diagram. Then we are going to make equilibrium equation, and then we are finding the forces using force method. This all full bar is statistically undetermined because of one thing, that is thermal loading. So this bar is subjected to delta T equals to 60 degrees Celsius. Let's first do the equilibrium equation. We are going to add the forces in X because there is no Y force and C direction of forces. So summation of Fx equals to 0, that we are going to do here. Now let's find from left hand side. First is AX plus BX plus 49,000 minus 20,000 minus, because this is a negative 1, is equals to 0. So these are the forces. So we get equation AX plus BX is equal to minus 29,000. So this is equation number 1. Now we are going to use force method. Third step is to use the force method, right? So this force method part I will explain in next video.